We are on top of a 5-story building, so there's 5 stories below us with a busy street in the middle of a busy street in town, so there's lots of foot traffic. This is one of the spandrels, a beam that extends around the window opening. About 80-90 years old, concrete, one of the earlier concrete buildings. What you can see here is significant amount of corrosion that's going on, and that water was seeping in. You can see that concrete mix actually has seashells in it, which is a good clue to tell us that there are salts inside. So you combine oxygen, chlorides and water, you get quite extensive corrosion flaking away. Keep in mind that we are 5 stories above a busy street, and this at some point recently have decided to let go and collapse down onto the street. So these things could be extremely dangerous if not addressed properly. So the steel flaking is really extreme, just because this problem has been left unattended for so many years that the corrosion is so extensive that it actually pushed the entire volume of concrete outwards, resulting in collapse under its self-weight. So there was no strong winds, there is no earthquake, it's just pressure from the steel that resulted from this fall down. And I'll show you downstairs solutions that have been used that were not as successful addressing this earlier. So here's another example. We're in the same building, but now inside. This is an interior, ground level. A beam supporting concrete floor above. You can see the beam is not really happy at all. Cracks, extensive cracks all across the bottom of the beam here. Really dramatic amount of concrete that is just being suspended in mid-air. What I really want to point out in this situation is someone has gone and tried to repair this, and the repair is simply a patch up the cracks that was coming up with this really strong grout based mortars, extremely strong stuff that you can barely break, but nothing can withstand the pressure of an expanding corrosive bar that's corroding. So that pressure just keeps going, and the concrete, you can see, is just so devastated. It's a real safety concern here, because you've got a heavy slab being supported above. So it will take a lot more sophistication and thought than simply patching it up like this and thinking that your problem is going to go away. That's just not the way you solve these things. Okay, I've got one more thing to show you. Have a look here. This is the main load-bearing supporting columns on the ground floor. So you have soil directly below us, underneath the foundation. So what we suspect is happening, we've got groundwater seeping in through the concrete and sort of making its way through the footing up into the base of the column. And that's of course creating moisture. You can see that there's real clear evidence of big seashells. You've got oxygen, moisture and salts. The results is pretty obvious. You've got a huge amount of corrosion going on. This causes the steel to rust and expand. As it expands, it pushes against the concrete, pushing all of this out, and you see the result of that happening right there with the loss of steel cross-section. So if you just patch this up, as I've shown in the previous examples, in the next couple of years that problem just reoccurs. You haven't really solved the cause of the issue. What you've done is simply patched it up. All of these stirrups that used to be down here, you can see the little imprints of stirrups. These are all gone, fully corroded away, and you've got some remnants of stirrups. So they will need to be replaced. But overall, quite an extensive set of corrosion going on. And we'll need to develop a clever solution to make sure this doesn't happen and we can repair it properly so that this lasts for many decades to come.